All right, you guys, this is the Unit 6 Algebra review. I'm going to work through the odds only to help you kind of get the idea of it. When you are combining same bases with different exponents, you are going to, we like to use MADS PM, where the M, the D, and the P are the properties that are happening in the problem. So if you are multiplying in the problem, the next letter is going to tell me what to do to my exponents. So that tells me I'm going to add my exponents. If I'm dividing in the problem, I'm going to subtract my exponents. And if I see powers raised to a power, I'm going to multiply the exponents. In number 1, you have a coefficient of 3 and variables a and b, but each are being raised to a power of 2. So since there's multiple things in that parentheses, each piece is getting that squared. So 3 is a coefficient, so it follows regular math operational rules. 3 squared is 3 times 3, which is 9. A has an exponent of 1 with power to a power that tells me to multiply 1 times the exponent I actually have, which is 2. So this would be a squared and b squared. Number 3 is x to the 4th, x to the 5th. When there's no operation sign in between, that's always a hidden multiplication sign. Since I'm multiplying in my problem, I'm going to add my exponents, which tells me this would be x to the 9th. Number 5. Coefficients, always deal with those first. It makes things a little bit simpler on you. So 8 over 4 is essentially the same thing as 8 divided by 4, which is 2. And x cubed divided by x to the 1st, that's a hidden 1 there. We're dividing in the problem, which following MADS PM tells me to subtract my exponents. And my rule of thumb is wherever the larger exponent is where my answer is going to be written. So I have more x's on top. I have x cubed on top. So I'm going to do 3 minus 1 is 2. So I have x squared more on top, which means I have x squared more in my answer. Technically, everything has been canceled out in the denominator, so that's over a hidden 1, which is not necessary for you to write. So your answer would be just 2x squared. Number 7. Number 7 is 8x to the 5th over 2x squared. Zoom in a little bit so y'all can see. 8 and 4 are coefficients, so I'm going to treat them like coefficients would be regularly. 8 divided by 2 is 4. And then I have more x's on top. Since this is division, MADS PM tells me to subtract my exponents. So 5 minus 2 is 3 more x's on top, so I write x cubed. And again, this is over a hidden 1. We've canceled out that 2 and that x squared, so you're left with 4x cubed. Number 9. Number 9 is x squared v cubed times x v to the 4th. This x right here has a hidden 1 exponent. Okay, so I need to make sure I remember to add that in. Kind of blurry, sorry y'all. Let it refocus for a minute. All right, there we go. Okay, so we are multiplying in the problem. According to MADS PM, I need to add my exponents. So x to the 2nd times x to the 1st. First, you combine your like bases, so this would be x cubed. V to the 3rd times v to the 4th would become v to the 7th. Since my bases are all combined that can be, and there's nothing I can simplify, that's the answer. All right, looking at number 11. Number 11 is pretty long, but we'll take it one piece at a time. Start with your coefficients, which are 12 and 1/2. There is a hidden multiplication sign in between all of this. So I'm thinking, what is 12 times 1/2? Well, that 12 is really over 1. When you multiply fractions, you multiply top times top, bottom times bottom. So this would be 12 over 2, which is 6. So the coefficient in front of my entire problem is going to be 6. Then I'm going to combine my like terms. This x has a hidden 1 exponent, and the z has a hidden 1 exponent, and the y in the second part has a hidden 1 exponent. So I'm going to combine my like bases. X's together, I have x to the first times x to the fifth. According to Mads PM, that tells me when I'm multiplying in my problem, I'm going to add the exponents. So that would be x to the sixth. Then I have y squared times y to the first multiplying, so I need to add my exponents. This would be y cubed. Z to the first times z cubed. I'm multiplying again, so I would add the exponents on z to get z to the fourth. My numbers are all combined. The coefficients are combined. My variables that are alike are combined, so that's as far as you can go. All right, on the back, number 13. Number 13, the coefficients are negative 33 and 11. Negative 33 divided by 11 is negative 3. A has nothing to combine with on the bottom, so this would just be A. B squared over B squared, when you have the same thing on top and bottom, it eliminates each other. Just like if you had 3 divided by 3, that cancels out to give you 1. So B squared over B squared eliminates. C over C eliminates. So you're left with negative 3A as your answer. Number 14, we have a negative exponent on the outside. A negative exponent means to flip it to the other side of your fraction. There's no fraction here. This is all on the top or the numerator of an invisible fraction. So if this entire thing has a negative exponent, we need to move it to the bottom to make it positive. 2SV is still on the top because we didn't change anything. It doesn't have a negative exponent, but I'm going to take all of that front part, 4s cubed t squared uv, and move it to the bottom. By moving it to the bottom, it makes my exponent change from a negative 2 to a positive 2. Now that I have the correct order, now I'm going to actually follow order of operations, which tells me to deal with exponents first. So I'm going to distribute this exponent of 2 to every little piece. 4 is a number, a regular coefficient being squared, so I think 4 squared, I'm not touching the top, so I'm going to leave that there. 4 squared is 16. S cubed raised to another power of 2. In Mads PM, that's the p part. So power to a power tells me to multiply the exponent. So this would be s to the 6th. T squared multiplied by 2 would give me t to the 4th. U and v have a hidden 1 exponent. So 1 times 2 would give me u squared. 1 times 2 would give me v squared. Now I need to start looking at what cancels out and what can be reduced. 2 and 16 again are coefficients. So 2 over 16 can be reduced to 1 over 8. We have an s on top, but we have 6 s's on bottom. So I look, okay, I have more s's on bottom, which means my answer is going to be on the bottom. And I think, okay, if this is x to the first, and I have 6 s's on bottom, that means I have 5 more s's on the bottom. So I would write s to the 5th. T has nothing to combine with, so it stays where it's at. U has nothing to combine with, so it stays where it's at as u squared. I'm going to make my fraction sign a little bit longer. And then v to the first is on top and v squared is on bottom, which means I have 1 more v on the bottom. So my final answer would be 1 over 8s to the 5th, t to the 4th, u squared, v. I accidentally did 14. I totally didn't mean to. All right. The next odd I'm going to work is number 17. Number 17 is c cubed d squared f over c to the negative second df to the third. First thing I'm going to deal with, I have no coefficients. Second thing I'm going to deal with, I have a negative exponent. This c to the negative 2 is in the wrong spot, which means I need to move it up to the top. So I'm going to rewrite this as c squared, c cubed, d squared f. Same thing on top, I just moved that c squared up there, and what's left on the bottom is df cubed. Okay, now I'm going to simplify and combine my like terms. C squared and c cubed are on the same line, which means they're being multiplied together. According to Mads PM, when I see multiplication, I'm going to add my exponents. So that would become c to the fifth. Then d squared is on top and d is on bottom, which means I have more d's on top and I only have one more. That one doesn't have to be written. And then I have f's to combine. There's more f's on the bottom, so I put my answer on the bottom. How many more are there? Well, that's a 1f on top, so there's 2 more f's on bottom, which makes that c to the fifth d over f squared. Number 19. We have a negative exponent on top, and we have power to a power on the bottom. So let's rewrite the top as 2ab and move that c squared down to the bottom to make it a positive exponent. So that's this right here. Now let's take the power to a power rule, which would be in Mads PM, to multiply my exponents. Since 4 is a coefficient, it follows regular math rules. 4 is being squared. So I'm going to rewrite the top and put 4 squared on the bottom is 16. Then we have a squared raised to another power of 2. That tells me to multiply those, would be a to the fourth. B and c both have a 1 exponent right now, so when I multiply that 1 times 2, we get b squared, c squared, and then we have that additional c squared that we moved to the bottom. The last step is going to be reduce your numbers and combine like terms. So we have 2 over 16 can be reduced to 1 over 8. We have 1a on top, 4a on bottom, so I'm going to subtract those. I have 4 minus 1 is 3 more a's on bottom. We have b squared on bottom and b to the first on top, which means I have 1 more b on bottom. C squared times c squared are getting multiplied, so that tells me to add my exponents. So that would be c to the fourth on the bottom. Numbers are reduced. Like terms are combined, so that would be your final answer for that one. All right, number 21. First thing I would deal with is to rewrite this as a fraction and put the correct pieces on the top and the bottom. So right now, we're looking at 1/2 as a fraction. 1 is on top, 2 is on bottom. These two right now are not in a fraction, so it's over an invisible 1. The first section has a negative exponent, which means that whole chunk is in the wrong spot. So I'm going to rewrite this. 1 times all of that is just 4a, b, c all being squared on top. And then we have a 2 from the fraction on bottom. And we're going to move this negative exponent all to the bottom. So that'd be 3a squared, b to the fourth, c raised to a positive 2 power now that it's in the right spot. So now I need to distribute those power to a power. 4 is a regular number, so it gets squared just like regularly. So that'd be 16. A, b, and c all have exponents of 1. So we're doing power raised to another power would be the PM part of Mads PM telling me to multiply. So this would be a squared, b squared, c squared. All over, do you see how that 2 is not in the parentheses? So this 2 is not being changed at all. It's just out in the front of the parentheses, so it doesn't change yet. The 3 is also another coefficient. It is being squared, so I do 3 squared is 9. A squared raised to another power of 2 tells me to multiply, so that would be a to the 4th. And then b to the 4th squared again would be b to the 8th. That is a c to the 1st. C to the 1st squared would be c to the 2nd. We have two numbers on bottom. There's an invisible multiplication sign between 2 and 9 because of the parentheses. So if I rewrite this, this would be 16a squared b squared c squared over 2 times 9 is 18, a to the 4th, b to the 8th, c squared. All right, I've combined everything as much as I can until now. Now we can combine by using the division property. So in Maths PM, that tells me we're going to start subtracting our exponents and reducing the numbers. So 16 divided by 18, they're both divisible by 2. If I reduce that, that gives me a fraction of 8 over 9. A squared over a to the 4th, we have 2 more a's on bottom, so I'd write a squared on bottom. B squared over b to the 8th, I have 6 more b's on bottom. C squared on top and c squared on bottom are going to cancel out. So our final answer would be 8 over 9a squared b to the 6th. Last one, number 23. Number 23 has fractions that are coefficients. So let's go ahead and multiply those fractions together. If I go off to the side, 3/4 times 5/6. When you multiply fractions, you multiply top times top and bottom times bottom. So this would be 15 over 24. Both of those numbers are divisible by 3, so when I pull that out, that would give me 5 over 8. So my coefficient for this problem would be 5/8. Now we have x, y squared, z times x, y, z to the 3rd. Now I need to distribute that cubed. So this would be x cubed, y cubed, and z cubed. Now the last step is going to be to multiply these across. So we have 5/8. X and x cubed can be combined. This is a hidden 1. Since we are multiplying these together, we're going to add the exponents. So that would be x to the 4th. Y squared times y cubed, add the exponents, would be y to the 5th. Z to the 1st times z cubed, add the exponents, would be z to the 4th. This is technically a correct answer. You could also write it as 5x to the 4th, y to the 5th, z to the 4th, all over 8, like that. Either one is a good answer choice. This is the one I wrote first, so I'm going to box that one as my answer, but both work. All right, I hope that was helpful. If you have any questions and you're still struggling with this, make sure you come into tutoring.